Hi everybody, welcome to another video in Math 1332 section 2.3 Venn diagrams and set operations. First, we have complement of a set. In order to define a complement of a set, we need to define a universal set. A universal set is the set that have all the objects in the universe. Well, this is the way we define everything to be the universal set. It's just the way we define it is so universal set for a given situation. We use U for that. It's the set of all objects that are reasonable to consider in that situation. So we might say it, if we want to, we can just say it, the universal set is the set of these four numbers. Yeah. So in that situation, we say it, universal set, we have those four numbers. Like that, it's just the way we define it. The complement of a set A denoted as A prime with the prime sign is the set of elements in the universal set that are not in A. So the complement meaning not in A. Using set builder notation, complement of A is the set of all the x such that x in the universe but x is not in A. So if we use the Venn diagram, we denote as follows. If we let the set A be everything in this circle and U to be a square or rectangle, then the complement of A will be everything outside of A but have to be in the universe. Of course, there's nothing out of the universe. Everything in the universe. I should say the universal set. Yeah. So that denote the complement of A. Something not in A. And we have this obvious result. If it's not in A, and then we do complement again, that will get back to A. Right. So A complement meaning not in A, but of course have to be in the universe. Universal set. Right. Let's look at some example. Let U be this set of V, W, X, Y, Z. Find the complement of A if A is W, X, Y, and draw a Venn diagram that illustrate these sets. Find the complement of the universal set, and then what is the complement of the empty set. Right. So first, we draw the Venn diagram for this situation. We draw a universal set that a rectangular U. Denote that by U. Then we'll try to draw a circle. Denote that by A. Now, in A we have W, X, and then Y. On the universal set we have V, W, X, Y, Z. So we already have W, X, and Y. We just don't have V and we don't have Z. So write V and Z outside of on the universal set, but outside of A, right? V and W, V and Z are not in A. Now find A complement. So complement of A is equal to not in A, so it have to be V and Z. Right. Next, what is the complement of the universal set? Everything is in the universal set. The complement of the universal set is an empty set, because if it is not in universal set, there's nothing that is not in the universal set. And what is the complement of an empty set? Well, if it is outside the empty set, pretty much everything is outside the empty set. So complement of an empty set is universal set. Right. Here we have a Venn diagram of this. What is the universal set? Well, universal set will be the set of everything square and triangle and then a dollar sign, M, and 5. Yeah, so everything in the universal set. In A, we only have a square and a triangle. So A complement, something that's not in A, will be these three, dollar sign, M, and 5. Yeah, so we have a universal set, the set that contains everything, and the complement, meaning not in that set, but still in the universe, still in the universal set. Right, so that is the first operation of set, the complement. Now we have three more. The intersection of two sets A and B symbolized as A and then upside down. So intersection of A and B is the set of elements in both sets. So intersection is characterized by the word both, meaning and is and. So intersection of A and B is in X, in A, and in B. When the intersection of two sets is empty set, the sets are said to be disjoint. Right? If they have nothing in common, it's said to be disjoint. So intersection of two sets is empty, then the sets are disjoint, meaning that have nothing in common. Intersection is equal to an empty set, so they have nothing in common. That means they are disjoint. Right, next the union. Union symbolize A, U, B is the element that is characterized by either or. So maybe in A, maybe in B, or could be both. So we write as follows. And finally, the difference of A and B is set in A but not in B. So in A but not in B. Right. Now try to draw a little Venn diagram for each situation. First, the intersection. We have the universal set. Now we have set A and B. The intersection is in both of the set, so it's overlapping. So that is intersection. Yeah, the overlap. Now, the union. A union will be in A or in B or both. So just like the whole MasterCard, simple. So pretty much in A, in B or both. And then the difference. So this is that in set A but not in set B. So meaning it's only in A but not in B. So only in A and not in B. So that's why we have the Venn diagram for each sum operation. Now, let's look at this example. Basically, we have that given Venn diagram. What is A union B? Or A union B meaning could be in A, could be in B, could be both. So we're going to write down everything, including I pi E two square root of 2 square root of -1, and then 3 e to the pi I 10 to 100, 10 to 100, and 2 to that. Right, so pretty much in A, in B, or both. Now, A union B complement, meaning whatever this is, we take the complement of that, meaning we're going to take away all of this. So what's left is just the 4 and 6, 6, 6. Right? So we find the union of A and B first, and then we take the complement, meaning outside of that. Next, intersection of A and B. Intersection of A and B are the overlapping. So the 2, square root of 2, and negative square of -1. So that is the overlapping of A and B, the intersection. Now, A and B complement, meaning that is not in this. So we have outside of the intersection here. So I pi e 3 e pi I 10 to 100, 2 to the that 4 and 6, 6, 6. Right. Next, A complement intersect with B. Right. Now, it's a little more difficult. So A complement meaning outside of A. And then intersect with B, so it have to be in B as well. So we're talking about this one. Yeah. So outside of A, but overlap with B, so it have to be that. So meaning this. And then A union with complement of B. So for this operation, we're going to do the complement first. First outside B. Outside B. Outside B, sorry. Yeah, just outside B. And then union with A. So we have that either in that or in A. So pretty much everything except for that. Everything except for this here. So except for those, we have everything. Yeah. So we just like that. So usually, unless that we do inside the parentheses first. If we have outside like this, do the complement first and then determine the union and intersection later. Right. So more on operation of sets. The set operation and the Venn diagrams provide precise way of organizing and classifying and describe vast arrays of set and subset. So all refer to union and refer to intersection and not refer to complement. Depend on the situation. That's what we do. So in reply we just have or and or not. A lot more than we don't usually see intersection or union, but we know that means union means or, intersection means and complement means not. We'll have plenty of example. This. Next, let the universal set be the set from 1 to 10. And A is 1, 3, 7, 9, and B is 3, 7, 8, 10. Find A, subtract or the difference of A and not in B, right? So let's just draw the Venn diagram for this situation. We have set A, set B. Right. A have 1, 3, 7, 9, and then B 3, 7, 8, 10. We see that they have 3 and 7 in common. So we're going to put 3 and 7 in common. A have 1, 3, 7, and 9, so 1 and 9. Like that. B we have 3 and 7, and then A and 10 outside. So outside, only on the universe and not in A or not in B have to be what's remaining here. So you have 1, there's need the 2, 3, 4, 5, and 6. We have 7, 8, 9, 10. Right, so that's what we have as far as the Venn diagram goes. Next, we do A different of A minus and B complement. Just going to sketch and see what happened. I don't want to draw in here. So set A, and then set B, complement. I'm sorry, that's just B. Right. Now, not in B, we're going to do that first. So that is not in B. Always do the complement first. Right. Next, this have to be in A, but not in the part we just mark. So, meaning that it have to be in A, but it cannot be the part that we mark with the pencil. So meaning that we're talking about this one, because that part is in A, right? But not in the complement of B. So we're talking about that, which is the complement, which is the overlapping here, so just 3 and 7. Once again, what we do is we do the complement of B, which is outside of B, and then we do A. But what we have is in A, but not in complement of E, meaning inside of A, but outside of the part that we just marked. So we just have that. Right, next. Have A and B. So first, outside of A, complement of A. And then complement of B. Sorry, complement of A. Be outside of A. And then complement of B. will be just outside B. So we'll see the part that overlapping of the two parents is just outside of A and B. So that will be 2, 4, 5, and 6. And then the last part, A and then B. Right. This one the complement, alright, but we have to do inside the parentheses first. Inside A and B, A union B, of course that's the MasterCard. That A union B, and then the complement of that, meaning we're talking about the answer will be outside of the MasterCard. So we're talking about this one. So the MasterCard is the union, and then we have outside that, so it'll be 2, 4, 5, 6. Right. So that is we do with the Venn diagram. Now we can certainly do this by hand and without any Venn diagram. Right. So first, A minus B complement. First we do the B complement. B complement is not in B, so will be 1, 2, there's 3, 4, 5, 6, there's 7, there's 8, and 10, so there will be 9. So this is not in B. And then we have A is 1, 3, 7, 9. Right. So A is 1, 3, 7, 9. Complement of B is not in B. So we write everything in U, but not in B. And then we subtract. A, the difference of A and not in B is it is going to be in this set, but it's not going to be in this set. Right? So in A, in this, but not in this. So when we look at this, we see 3 and 7 belong to A, but not in B complement. So we say A, difference of A and B complement is 3 and 7. That belongs to A, but not belong in B complement. I said we can do that without the Venn diagram. Right. On the second one, intersection of A complement and B complement. First we do A complement. Not in A will be 2, 4, 5, 6, and 7. Then it will be 8, 9, and 10. So that is 8 complement. Then B complement. Be not in that. So be 1, 2, 4, 5, 6, and 9. So we have A complement, B complement. The question asks for A complement intersect with B complement. So we just find the intersection of these two. A complement intersect with B complement. So what do they have in common? 2, 4, 5, 6, 2, 4, 5, 6. Like I said, we can just do step by step. Always do the complement first when we see this. And then we do the intersection. Right, just based on definition. Complement meaning not in that set. Intersection meaning the overlapping of these two. Just like that. Right. Next on this one, we do it by hand as well, without the Venn diagram. A union B. Well, this is A, this is B. The union meaning in A, on B, on both. So we say 1, 3, 7, 9. We have only 3 and 7 already. Now we have A and 10. So A union B is in A or in B or both. Now we find the complement of that. So not in this set, but in universe, in the universal set. So there's 1 already, there's no 2, there's 3, there's no 4, there's no 5, there's no 6, 7, 9, 8, 10, so everything. Yeah, so as you see, we can do this without the Venn diagram. Just use the definition. But of course the Venn diagram also works. Right, so that is that. Next we have the little formula here that says that the kernel number of the union is equal to kernel of each set minus the overlapping. Well, that's the proof is very simple. Just do that by drawing a Venn diagram, if you will. So if say we have the set A here, and then the set B. Now pay attention here. If we count everything in A, we're just gonna mark that for A, and then we mark the for B. Right? So that is the union. Now, as you see, the overlapping we count twice. So that's why when we count A in B, we have to subtract what in the overlap, because the overlapping we call it twice. So I have to take one of it out. So A in B, and then subtract the overlapping or the intersection. So that's what we have. Right. So we have an example for that. Some of the Arizona campus blood drive indicate that 490 students were willing to donate blood. 340 willing to serve free breakfast, and then 120 are willing to do both. How many students are willing to donate blood or serve breakfast? Right. So we draw a Venn diagram here. First, we have 490 to donate blood. I'm not going to put 490, I'm just going to draw it. This is what blood donation. And then we have another one who serve breakfast, blood and breakfast. Now, in order to do this kind of thing, we're not going to put 490 here and not going to put 340 there. What we actually have to do first is look at the one that said both. So we have 120, that is both. And then we say blood, then 490 willing to donate blood. 490, take out the 120. We have 370. Donate blood only. And then for breakfast, breakfast 340 willing to serve breakfast. I have to subtract the 120, that overlapping. I have 220. So with that, the question is, how many students were willing to donate blood or serve breakfast? So blood or serve breakfast, pretty much we add all of this. 370 plus 120 plus 200, 22. Right. So we have a calculator there and we haven't used up to this point. Right, so that's 7 and 10. This is either donate blood or serve breakfast. Right, so that's nice and all, but we have the Venn diagram like that. If we don't want to use that, just use the formula. We have the N is the number of donate blood or serve breakfast is equal to N of only blood plus N of breakfast minus the number that willing to do both. this will overlap, we can calculate 2 times, so we have to subtract from this. So this is what we ask to donate blood, 490, to willing to serve breakfast, 340, and then we have to subtract the overlapping, which is 120. And we'll do all of that. And we have 7 and 10. Right. So that just confirm our calculation. Right. So with that, we finish section 2.3 in Math 1332. As always, thank you for watching.